Welcome back to part 3 of making Snake with Unity's Project Tiny. In the last video, we made the tail of our snake, and we made it to where the snake's tail follows the snake's head wherever it goes, as you would expect for a snake game to work. In this video, we'll be making the food system. We'll be spawning the food in and allowing the snake to be able to interact with the food to grow the tail, so it's not just done off of a key down like we did in the last video, and instead it'll only happen when our snake actually interacts with a piece of food. So the first thing we'll want to do is create our food scene. So go to create, scene, and we'll call it food scene. We can then open this scene up and we'll create an entity inside of it, and we'll call this food. Then on the food entity, we just need a sprite 2D renderer so we can display the food onto the game. And it's going to use the same graphic as our snake because it doesn't really need to be a different graphic. You could even change the color if your snake graphic wasn't black, but since mine's black, no matter what color I use, it's going to multiply to end out being black. If you used white for your snake head, you could actually change up the color of all these pieces in your project, but that's something that you would have to do differently than what I'm doing. So once we have our food created, it doesn't matter if it's centered or not because our system's going to relocate it anyways. We're going to create a new component called a food tag to be able to locate the food within our system, and we'll also have a variable or two on it to be able to do some things to it. So let's create a new C# system, which isn't going to be a system but actually a tag, but that's the only button Unity has for us. Let's call it food tag. And after we create this system, as always with Unity's Project Tiny, we'll have to go to Assets, Open.C# project for our IDE to recognize the script. So open up your .C# project and make sure to open your food tag file. Once your food tag file is open, let's change the class to a struct. Let's change the component system to a iComponentData. Get rid of your protected override. We'll create a variable called public bool should move, and this variable will be to move our food around on the map when the snake does interact with it. And we're going to automatically set it to true so that when the game starts or when the food is spawned into the game, it's going to automatically relocate itself to a random position in the screen. So to automatically set it to true with Unity's Project Tiny, we'll say public static food tag. Then we'll say default get equals new food tag. Get rid of those parentheses that it auto-typed if your ID auto-typed it. Put brackets instead with a semicolon on the end of it. And here we're going to say should move equals true. Now that we have our food component created, let's save the file, go back into our Unity project, and we'll add the new component to our food. Click on your food entity, go to add component, and type in food tag. You'll notice that it's located in the global section. That's because we forgot to put it in our namespace. So let's go back into the IDE and add it to our namespace. We'll say namespace snake. Go ahead and resave and go back into your Unity project to see that it is now organized with the rest of your snake files. iComponentData, snake, food tag, and we have our should move variable, which it doesn't seem to automatically set it to true, which is strange. So I'll go ahead and set it to true, but maybe it is and it's just not being displayed in the IDE. Not sure. Oh, we misspelled default, that's why. So I think if I remove it and re-add it, it should say should move is set to true. Let's try. Cool. Should move is set to true. See if I set it to false, removed it, and re-added it, it's automatically set back to true. Now that we have our food entity created with the food tag component so our systems can find it, let's create the food eating system to spawn it into the world and randomly relocate it. So we can save our food scene and unload it. Then go back into our IDE. Then we'll go into our scripts folder and we'll create a new C# system and call it food eating system. after creating the new file, go to Assets, Open.C# project. Put it inside of your snake namespace. And then what we're going to want to do in here is we're going to create a new protected override void, and what this one's going to be called is onCreate. After creating the protected override void onCreate, let's make a new variable. The variable is going to be a random, and what we're going to call it is _random. And if you take your mouse and hover over it, it says UnityEngine.random, but we really want the Unity.mathematics.random. So how we're going to fix that is we're going to say using random, which is the name of the variable we're trying to access. Then we'll say equal Unity.mathematics.random. So every time we use the random variable, it'll automatically point to this library instead of Unity 3D's other random library. Now, what we're using this for is to access the random locations on the screen that we'll be moving the food around to. So in the onCreate, we're going to want to say _random is equal to new random. Then we're going to say _random dot initiate state. This will initiate our random variable that we created when the game is created. Now inside of our onUpdate void, we can check and see if the food exists in the world or not. And if the food does not exist, we can go ahead and load it in. So we'll say if entity manager dot exist, and then how we'll find the entity is by saying world.tinyEnvironment.getEntity by name. The name that we named our entity was just food. Then we'll add an exclamation mark, and if the game is not able to find an entity with the name food, we'll go ahead and load in a new food entity. So we'll say scene service dot load scene async, and the scene that we're gonna want to load will store inside of the game config. So let's go inside the game config, make a new scene reference, and we'll call this food scene reference. We can save this and go back into our editor and add the food scene that we created to our game configuration component. Line out your error so that your Unity will actually compile. Go into your scenes folder, find the food scene, go to your configurations, and drag the food scene into the new variable spot that we just created. Now we can go back into our IDE, and we can say scene service.load scene async inside of our food eating system. Then we're going to access our game config, which we'll store right here by saying var config equals world.tinyEnvironment.getConfig data. The config data that we want is the game config. Now that we have it stored in a variable called config, we can say config.foodSceneReference. So when the food eating system is initiated, the random variable will be set up with the onCreate void. Then inside of the onUpdate, we'll search for our food entity. If it doesn't exist, we'll load a food entity in. Let's go back into Unity and click play and see if our food entity spawns into the game. You can see we have a square right here in the middle of the game that is not a part of our snake, because if we push snake, our tail will grow, but that one will stay where it is. So that must be the food entity that we just loaded in. So our code should be working. Excellent. We could also store if the food exists inside of a variable so we don't have to keep doing this call every run of the onUpdate void, but I'll leave that up to you to decide if you want to do. So now that we've loaded the food into our game, let's create a way for our snakehead to interact with the food. And at the time of creating this video, Unity Tiny does not have physics implemented into it, so we'll be using the old-fashioned way of math.distance to determine whether or not our snakehead is close enough to our food for an interaction to take place. And to do that, first we're going to do a for each loop to find the snakehead. So we'll say entities dot for each entity. Then we'll reference the snakehead, call it snake. Then we'll reference his translation so we can figure out where the snakehead is at, and we'll call it snake transform. We'll make our lambda expression in the open and closed bracket. Now let's store the snake transform into a variable by saying float3 snake trans is equal to snake transform dot value. Then let's also make another variable that we'll store the food transform into by saying float3 food trans is equal to new float3 because we'll store it here in a minute. Then we're going to do another for each loop to find the food that we just spawned in. So we'll say entities dot for each entity. Now we need to reference the food tag that we created. We'll call it food tag. Then we'll reference its translation so we can figure out where the food is at on the screen. We'll call it food transform. Make your lambda expression in an open and closed bracket. We'll need to rename these entity variables because we can't have two variables of the same name within the same scope. The compiler does not know how to deal with that, so to fix that, we'll call this one snake entity. And for organization's sake, we'll call this one food entity. Then inside of the second for each that we created, we'll say food trans is equal to food transform.value. Now we're going to do our for each loop by saying math.distance between the snake trans and the food trans. If that value is less than 1, we'll perform our interaction code. What we're going to do first is just move the food around when we interact with it. So let's create a new void to move the food around. So outside of your protected override on update, create a private void move food. Then inside of our private move food void that we created, we'll pass in a reference to the food entity by saying entity food. And then in here we can say move food, passing in the food entity. Then within this function, we'll say var translation is equal to entity manager dot get component data. The component data that we want is the translation, and we want it off of the food entity that we passed through. Then using that translation variable, we can say translation dot value is equal to underscore random dot next int3. Then we'll say new int3, and we're gonna hard input the size of our screen, but you could use the same code from our snake movement system to figure out the correct positions of your screen. But for my screen, it's -15, -9, 0, and then we'll say new int3, 15, 9, and 0. The reason I use -15 through 15 and -9 through 9 is because my orthographic screen size is 10, and I know that the X size of that screen size at my resolution is 15 and the Y is 10. But like I said, if you want to put in the correct values for your screen size and you're not using the same screen size as me, you can figure out the hard-coded values or copy the same code from the snake movement system that we created earlier. But after we set the translation.value, we'll say entity manager.set component data. The entity that we want to set the component data on is food, and the component we want to set is translation. So let's go back into our Unity editor, click play, and see if our food moves when our snake interacts with it. Cool, it does, but it seems to have spawned a second piece of food into the world. So one way we could fix this is if we just store whether or not the food entity has been created inside of our game config, we can use that to prevent it from being spawned again. So we'll just say public bool food exist then we can go back into our food eating system where we spawn the food in at, and we can say and config dot food exist is equal to false. Then we'll say config dot food exist is equal to true, and we'll set the component data by saying world dot tiny environment dot set component data set config data. The config data that we want to set is config. So let's go back into our Unity project, click play, and see if our food game only spawns one piece of food. Excellent, it seems to be working. The last thing that we're going to do is move our code that's inside of this if statement for the space button inside of our snake movement system for spawning in a snake tail into the initiate tail system. The way we're going to do that is by going to the snake head and creating a variable for whether or not the snake head should grow a piece of its tail. So we'll say public bool grow tail, and then inside of our food eating system we can say snake dot grow tail is equal to true, which we'll not actually be able to do because our snake is on the outer for each loop and we're within a new for each loop. So we'll need to create a variable for whether or not the snake should grow its tail. So let's go outside of our for each. We'll say var should spawn is equal to false. Then instead of snake.growTail is equal to true, we'll say should spawn is equal to true. Then outside of our second for each loop, we'll say if should spawn snake.growTail is equal to true. Now that we're setting the snake.growTail to be equal to true, we can go into our snake movement system, get rid of this if statement and the should spawn statement that we created, which means we can also remove this variable. Go back into your initiate tail system, and we'll create the tail spawning within this system. To do that, we're going to say bool grow tail is equal to false. Then we're going to do a for each loop to find the snake head by saying entities dot for each entity. Then we need to reference the snake head. We'll call it snake. Write your Lambda expression, the open and close brackets. Then inside of here, we're going to say if snake.growTail with a explanation in front of it, which means if the snake.growTail is equal to false. If it is false, we'll return, and we don't want to play any more of the code within our for each loop. But if snake.growTail is equal to true, we'll set this growTail variable that we created outside of the for each loop to be set to true so that we can spawn the tail. Then we need to set the snake.growTail to be equal to false because we're currently creating it and we don't want to create more than one at a time. And now outside of our for each loop, if growTail is equal to true, we're going to spawn in a new tail by saying scene service dot load scene async, and the scene that we want is on the game config file. So we can say world dot tiny environment dot get config data game config. The data that we want is the snaketail scene reference. Let's save, go back into our Unity project, click play, and see if it works. So we're moving around. If you click space, no tail is created. If we hit the food, a tail piece is created. let's pick up a few more pieces of food just to confirm this is working. And while we're at it, let's make sure the screen wrapping is still working with our tail pieces. You can see that everything seems to be working. The only thing we have left to do is to add the tail collision system so that if we run into our tail, our character will actually die, and we need a UI to keep track of our score. But I think I'll save that for the next video. I hope you enjoyed this video, and if you did, please consider liking and subscribing. It would really help my channel out. And if you have any feedback or suggestions, always feel free to leave it in the comments section below. Until next time, have a wonderful day.